Let's continue in section 1.6. We finished talking about rational equations, and so now we want to talk about a radical equation. And you probably guessed that a radical equation is an equation with a radical in it. So if you look at this first example, there it is. There's a radical. Usually the radicals we see are square roots, but occasionally you might find a third or a fourth root as well. So we'll talk specifically about square roots in these examples. And so there are two key ideas when we're solving radical equations. The first one is to isolate the square root and then square both sides. So in this first example, you can see that the square root is already isolated. That means that it's alone on one side of the equal sign. And so we could go ahead and square both sides. And the other key point is just to check your answers to make sure that they really are correct. And so we'll talk about that some more at the end of this first example. Okay, so isolate the radical. There it is, that's already done. And so then we can just go ahead and square both sides. And the squaring is essentially the opposite of the square root. And so the square root and the square cancel, and we're left with 4x plus 13 on the left. And on the right, we have 4x squared minus 4x plus 1. And frequently I see a student who tries to square 2x minus 1 or something like that, and they forget the middle term. So just be real careful when you're doing a problem like this, and make sure that you don't forget the middle terms. If you want, you might want to come out on the side and see 2x minus 1 times 2x minus 1, and then when you FOIL that out, then that might help you to see the middle terms. Okay, so look, the good news is this radical equation turned into a quadratic equation in just one step. And so we can just go ahead and solve the quadratic. Since we have a positive leading coefficient, that's the coefficient on x squared, we like to have that. And so let's not subtract it to the other side and make it negative. Let's just leave it where it is, and let's bring these terms from the left over to the right. So let's do minus 4x on both sides, and let's do a minus 13 on both sides. And so we've got our quadratic set equal to 0. And then we can make a decision whether we want to use factoring or the quadratic formula to finish solving. So at this point, it might be nice if you just switch the two sides of the equation, just because we're used to seeing the 0 over on the right. So you could certainly write this as 4x squared minus 8x minus 12 is equal to 0, if that feels a little more natural or a little more comfortable. And then notice that all four terms are divisible by 4. And so let's divide off that factor 4, and we'll have x squared minus 2x minus 3 is equal to 0. And the factoring is not too bad, right? The leading coefficient now is 1, so we can just look for two numbers that multiply to negative 3 and add up to negative 2. And so that should be x minus 3 and x plus 1. And so there's our factored form. And so we're almost done. We're just going to set each factor equal to 0. And solve. So x equals 3 or x equals negative 1. Now, I'm not going to box this up yet because remember, there was one more thing we have to do. We have to check. We must check our answers. So let's do that first. and then I'll try to explain why it's so important in this particular problem, in this particular type of problem. So let's go ahead and check x equals 3. And let's just plug into the original equation, right? So we have a square root of 4 times x plus 13 on the left. And on the right, we have 2 times x minus 1. And it's a question. Is it a true statement? So let's simplify. Underneath the radical, you have 12 plus 13 is 25. You have root 25. On the right, you have 6 minus 1 is 5. That is true. Square root of 25 is 5. So x equals 3 is good. And then let's go ahead and check the other solution. Check x equals -1. And we would get 4 times -1 plus 13 is equal to 2 times -1 minus 1. And that's a question again. This time on the left-hand side, we have -4 plus 13, which is the square root of 9. And on the right-hand side, we have -2 minus 1, which is -3. So this is not true. The square root of 9 is 3, and that is not the same as -3. So no, -1 is not a solution. There's only one solution in this case, and that's the 3. So let's write it again, maybe use the set notation, and be sure to put a box around it to show it's your final answer. Okay, so that's a little tricky with the checking. We haven't been checking our answers very much, and so now we have to do it. Let me show you an example here of why we must check our answer. Let's just come out to the side here. You know, we're taking an equation like just something real easy, like x equals 2, right? And we're saying, well, let's square that. Or you know what would be even better? Let's say x equals -2. It doesn't really matter either way. But x equals -2. And then if we square that, then we get x squared equals -2 squared, or x squared equals 4. Well, so of course squaring both sides was the big step, was that key step right at the beginning of our solution. And so notice what happens now. Is this equation that we were given equivalent to the one that we made when we squared both sides? No, these are not equivalent. Not quite. It's close, right? But you see what happened in this first equation, x is -2, and in the second equation, x could be -2, that's true, but it could also be +2. So there's an extraneous solution that was introduced when we squared both sides. So that's the reason we have to go back and check both answers, check our answers to make sure they really work. Okay, let's go on and work another example. You could try doing it for yourself before we do it together, if you like. Remember, the first step is to isolate the radical and then to square both sides. So in this case, the radical is not isolated yet. In this case, we need to move the x and the 4, the -x and the +4 over to the other side so that the square root is isolated. So let's go ahead and add x and subtract 4 to both sides. And then the x's cancel and the 4's cancel, and we're left with the square root of 2x is equal to x minus 4. And so now square root is isolated. Let's go ahead and square both sides. And we'll have, let's see, the square root and the square cancel, and we're just left with 2x over on the left. And then on the right, we have x squared minus 8x plus 16. So we have another quadratic equation, and we can solve it. We can subtract the 2x from both sides, and we'll get 0 is equal to x squared minus 10x plus 16. If you want, you can switch the two sides of the equation. I guess I like to do that, although it's certainly not too important one way or the other. And then we can factor this if we say x minus 8 and x minus 2. And so then you can have x minus 8 equals 0, or x minus 2 equals 0. And our two solutions would be 8 and 2. And so don't stop there. Go ahead and check your solutions. If we check x equals 8, then that gives us, back into the original equation, right? We'll have the square root of 2 times x, in this case 8, and then minus 8 plus 4 is equal to 0. And it's a question. And of course, we can simplify under the radical. 2 times 8 is 16, and the square root of 16 is 4. So 4 minus 8 plus 4 is equal to 0. And when you add those up on the left, you do in fact get 0. So that one worked. And then we can go ahead and check the other one. Let's see, let's write check x equals 2. And this time we get square root of 2 times 2 minus 2 plus 4 equals 0. And so that's a question again. Square root of 4 is 2. 2 minus 2 plus 4 equals 0. No, that's not true. 2 minus 2 is 0 plus 4. 4 is not equal to 0. So that's no good. So we only have one answer, and that's x equals 8. So we can go ahead and put it in set notation, put a box around it to show that's the final answer.